Welcome to section 1.2 of this class. Now, I want to remind you guys that this video should be a supplement to actually reading the textbook. You should also be reading the textbook, not just watching these videos. But today, we're talking about the basics of data. So, topics to take note on. What is a variable? What is an observation? What are the types of variables? And what are possible relationships between variables? Now, we'll also talk about some keywords: associated, dependent, which could be positive or negative. And we'll also talk about independent. Okay, so these are words to look for during this talk and while you read. Okay, so say we have this classroom survey, and it was conducted on students from a different stats course. And here are some questions in the survey corresponding to variables in the data responses were stored in. Gender. So we asked from a different class, the students were asked what their gender was, and they were asked if they were an introvert or an extrovert, and they were asked how many hours do they sleep at night on average. They were asked what time do you usually go to bed, and they were asked what countries have you visited, and then dread on a scale you can't really see, I'm in the way. On a scale of 1 to 5, how much do you dread being in that course? So then you can collect the data. So this was a large class. I think it might have been at Duke. That's where one of the instructors from one of the authors of the textbook teaches. And so there's an index number 1 through 86. And some of the students are male, some are female, some were extroverted, some were introverted. And then their dread could have been 1, 2, 3, or 5. 1, 2, 3, 4, or 5. So that's an example of how you could store data. And so a variable corresponds to how you would store columns. So it would be a property of each person. So an answer to each question would be a variable. And so the variable gender would be male or female. Would be 2 possibilities. Then the variable dread would have 5 possibilities, and so on and so forth. Each row would be an observation. And so in this case, like a particular person, so person number 3 is a female student who's an introvert and dreads this course with level 4. Okay, it was talked about a lot in stats world, that at the beginning of COVID, the UK, England, United Kingdom, one of their government agencies, doing some sort of COVID tracking. I can't remember what, but they were putting all their data in backwards of what this is supposed to be like. They're putting their variables as rows and their observations as columns, and they ran out of columns in Microsoft Excel at like 32,000, or maybe it was less than that. I don't remember, but it was like a big deal because all of us who teach stats all laughed at them. Anyway, moving on. Types of variables. So variables can come in 2 different types: numerical or categorical. And then numerical, we can break into continuous or discrete. And then categorical, I have that grayed out because it's not as important. But you can be regular, categorical, or ordinal. So a great way to figure out if it's numerical is if I add 2 of these together, does that make sense? So for instance, if I ask you guys, or if I average them, can I average these numbers? So if I ask students from this class like their heights, then I can average those heights together, and that makes sense. But if I ask for the student IDs and I average those student IDs together, that doesn't make sense. So your student ID is not a numerical variable. It is a categorical variable, even though it's numbers. Okay, so don't just think it's a number, it's numerical. No, it's about if averaging those things makes sense. And then numerical and discrete tells you about the average. Will the average make sense? So if I take the heights of students from our class and I average them, I get a new height that makes sense, okay? Like somebody could have the average height. Whereas like if you look at, say, families in our city and the average number of kids, then like the average number of kids could be like 2.3 kids, and nobody has 2.3 kids. You have to have a whole number. So that's when a numerical variable is discrete, is when the average might not make sense. You can average it like 2.3 kids, or the average college student has 0.7 TVs in their dorm room. It has to be just one or two, it has to be a whole number. So discrete is when there's holes in between the possibilities. So for instance, TVs in dorm rooms, you can have 0 or 1 or 2. You can't have half a TV or 0.375 TVs. So that makes it discrete, whereas continuous, like it continues, like all the possible values make sense. Okay. Let's see, what's next? Okay, well, now let's look at our example here. And I want you guys to think, gender, is that numerical or categorical? And if it's numerical, what kind is it? Is it continuous or discrete? So if you don't know, pause your video and think. But I'm also just going to give you the answer right here. So gender is a categorical variable. Okay, now let's think about sleep. Let's look at some of the examples. 5, 7, 5.5, 7, 3, 3. Who are those people? Like, that's crazy. All right. So these crazy people sleeping 3 hours a night. Sleep, is that going to be numerical or categorical? And if it's numerical, is it continuous, or discrete? And it's numerical, continuous, because just because people are putting in whole numbers most of the time doesn't mean it's discrete, because a partial number would still make sense. If I told you I slept 7.821 hours last night, I would be a weirdo, but I could still say that, right? So bedtime. What kind of thing is that? Is it numerical or categorical? And if it's numerical, is it continuous or discrete? Well, it's categorical ordinal. Why? Because it's an interval of time. So it's not a particular number. And since it's an interval, you can't average an interval. You could like pick the middle part of the interval and then average things, but we don't have that. We have an interval. And so, but you can order them. So 10 to 12 is before 12 to 2. So ordinal means ordering. You can order them into there's a natural order for those answers. All right, countries you visited. Okay, how can we, what sort of variable is that? Is it numerical or categorical? And if it's numerical, is it discrete or continuous? The answer is numerical, discrete, because you can't visit half a country. But you can average how many countries the class has visited. All right, what about dread? So they're being asked, this is often called a Likert scale. So 1 to 5, how much do you dread this course? And is it numerical or categorical? It's categorical ordinal. It also could be numerical, but that's tough. This is a tougher one. So it ought to be ordinal, because if you're averaging those numbers, you're assuming that someone putting down a 5 is only a little bit more than a 4. But when you think about, like, when you're being asked how much you dread a course, then putting down 5 is often like 10 times more dread than putting down a 4, right? So you're making a huge assumption about how people are answering if you think it's numerical. It's much better to put it ordinal, but sometimes people think of it as numerical and they still try to average it. Okay, let's do another practice question now. So your telephone number, or even not even just the telephone number, but the area code, just the first 3. So is that a numerical continuous, numerical discrete, categorical, or categorical ordinal? Okay, think about it. Try to figure it out. I'm going to give you the answer in 3, 2, 1. The answer is categorical. Okay, it's not numerical because you can't, like, averaging people's phone numbers doesn't make any sense. And it's not ordinal because who do you know orders their telephone numbers by, like, their friends' telephone numbers by, like, the smallest to largest? Nobody does that. So it's just plain categorical, even though it's numbers. You have to think about how are the numbers actually being used. Okay, now let's talk about relationships among variables. So here we have a survey of college students, and we asked them about their GPA and how many hours they studied per week. So can you spot anything unusual about the data? Well, this is where you want to be thinkers, critical thinkers about this. So the thing that is probably the most unusual might be that guy right there. Who in college has a GPA above 4? I mean, you can get a GPA above 4 in a lot of high schools, so like the weird AP stuff, but not in most colleges. Most colleges, you're capped at 4.0. You can only get A's. You can't get better than that. So this person's probably like a data entry error. Okay. Now, all right, we'll get back to that in a second. All right, so now let's talk about the relationships between variables. And we're breaking that down into associated or independent. So when 2 variables show a connection with one another, they're called associated. And they can be, so another word for associated is dependent. And if they're both numeric, then they can be positively or negatively associated, okay, depending on the line of best fit. And if they're not associated, then they're independent, meaning they don't really affect each other. So let's look at this scatter plot of skull lengths of possums. This is the fun thing about statistics, is that we just get to jump around all sorts of areas. So we went from like behavioral science to the naturals to biology. So now we're looking at possums and their skull lengths and widths measured in millimeters. So we measured a bunch of skulls of possums, their length, their width, and then we plotted them. So each individual possum is a dot and representing, and it's placed representing the length and width of its skull. So now we're asked, is there no relationship between the head length and skull width, i.e. they're independent? Or are they positively associated? Or are they negatively associated? Or does a longer head cause the skull to be wider? Or does a wider skull cause the head to be longer? Okay, there's only one correct answer given what we know. And that answer is 3, 2, 1. Head length and skull width are positively associated. Okay, they're positively associated because the line you might draw has a positive slope. And why did we not do answers D or E? Well, this doesn't tell us anything about the cause. It only tells us there's a correlation, or there's an association, okay? So we don't know anything about the cause because we just have some observational data, okay? And there's going to be 1 or 2 trick questions in the homework involving that. All right, that finishes section 1.2.